We present PointShopAR, a novel tablet-based workflow for supporting environmental design prototyping using point cloud in augmented reality. Most AR authoring tools only allow users to import virtual objects to an environment, but oftentimes designers need to modify their current spatial context directly to explore design ideas. For example, if a spatial designer was asked by a client to renovate an office, they need to explore many environmental design ideas and visualize changes to the physical environment, such as how the office will look like if the designer turns the desk around or takes down a wall. This can be very costly if the designer iterates design ideas physically. Modifying a replica of the environment would have been easier, but traditionally, the designer would need to measure the dimensions, build and edit 2D blueprints and 3D models in some CAD software. This has a steep learning curve and requires years of training to master. We first conducted a formative study with 6 professional architects to understand how designers use their spatial context for environmental design. We carried out open-ended interviews with 2 goals: understanding how designers capture and edit spatial context when designing for a physical environment, and identifying challenges in their current workflow and what limitations they are facing with their current tool set. Based on these interviews, we distill our design considerations for developing the PointShopAR system as follows. First, users must be able to capture their spatial context easily and quickly. Our capture representation must be amenable to rapid prototyping. Second, users must be able to edit the 3D capture using intuitive and direct interactions, such as selection, 3D manipulation, hole filling, and drawing. Third, users must be able to experience and iterate their design in situ and animate objects to illustrate new functionalities in the design. We then developed PointShopAR, a novel tablet-based AR system that supports environmental design prototyping using point cloud instead of 3D models and integrates capture and editing in a single application. The interface is implemented using Apple's ARKit and runs on an iPad with a scanner module and an editor module. We also run a lightweight server on a laptop, implemented using Python and Open3D to process point cloud reconstruction, segmentation, hole filling, and morphing. In PointShopAR, the designer can use the LiDAR scanner available on consumer tablets like iPads and quickly capture their 3D spatial context. He can load the capture in the form of a colored point cloud in just a few seconds. And then he can walk around to view the scan in AR. In the editor mode, he can select the task by tapping a bunch of points on the object to create an initial bounding box. The user can rotate the bounding box and adjust the faces of the bounding box to make sure it covers the object he wants to select. Once the user is done with adjusting the bounding box, he can separate the selected points to cut the desk out of the original scan. He can then rotate it and see if it fits facing the wall. To fill in the hole, he can use the impending feature and tap a few points on the floor, and send a request to the impending module on the server. A point cloud patch can be generated in just a few seconds to fill in the hole. Similarly, the user can select points on the wall between 2 offices and remove them. After this modification, when he walks into the second office, he can see the first office through the newly cut out door. Next, he can use the animation function to test out how this desk can be converted into a standing desk. He can move closer to the desk and get a physical sense of the ideal height. He can also import 2 plants previously scanned or converted from the mesh, and use the morphing function to generate in-between plants to decorate the office. Finally, the user can use the drawing function to extend the desk. First, place a canvas using the iPad, and then he can draw points on the previously placed canvas. And here is the final environmental design of the two offices. PointShopAR has many other application scenarios, such as turning a round table into an extendable table. We can also make the window wider on a building facade and add another door. We can also redesign the backyard by removing the plants and adding a new picnic table and a tree. In the last example, we show a redesign of the living room where a part of the wall behind the TV was removed. Comparing the recording of the physical environment and the recording of the edited point cloud, we can have an intuitive in situ experience of the new design. Residents will have more direct access from their bedroom to the living room, as you can see here. We evaluated the PointShopAR system with a user study to understand how our integrated point cloud capture and editing workflow could support users to rapidly prototype environmental design ideas in AR. We invited 10 participants to pick a location, develop an open-ended design concept, and realize it on site using our PointShopAR system on a LiDAR-equipped iPad. On average, participants spent 48 seconds on scanning their physical environment and 21 minutes and 26 seconds on editing. They performed a variety of editing operations such as replacing furniture and adding fun animations. Overall, most participants felt that it was easy to capture the environment for their design. It was also easy for them to understand the space by looking at the point cloud, and it would have taken much longer if they did the design physically. Among all the features, participants liked point cloud capture and import-export most, as they are the foundation for remixing point clouds. Their ratings of selection, manipulation, and animation were also mostly positive. Our user studies verify that a point cloud representation and an integrated capture and editing workflow are beneficial for supporting environmental design prototyping in augmented reality. In conclusion, we present an initial set of point cloud operations that are analogous to those in Photoshop. We chose to use point cloud as the underlying representation, achieving a balance between reconstruction quality and prototyping speed. PointShopAR enables an integrated capture and editing workflow on a single mobile device, and demonstrates that point cloud is a suitable representation for rapid AR prototyping. Some future work includes sketching with point clouds to provide a more fluid experience, and new techniques for point cloud rendering and editing, such as shape abstraction, instance segmentation, texture-aware inpainting, and tools for spurring, morphing, and sculpting points. Thank you for listening.